Hello, everybody. My name is Andrew Thiessen. I work for the MITRE Corporation, and I am the chair of the Next-G Alliance's Spectrum Working Group. With me today, I have Eddie. Eddie, why don't you go ahead and introduce yourself?
Thanks. My name is Eddie Kwon. I'm serving as the chairman of Technology Working Group in NGA. I'm currently working for Qualcomm. I'm honored to be invited to this panel session, providing Technology Working Group views on some key 6G aspect. Thank you.
Awesome. Thank you, Eddie. And Raza?
Hi, thank you, Eddie. Hi, everyone. I'm Raza Rafi. I'm Vice Chair of Spectrum Working Group of Next G Alliance, and I work for Intel Corporation.
Thank you, Raza. And so we're going to get right into it for this 6G Technology Solutions panel. So Eddie, the first question is for you. What are the biggest drivers from a technology perspective enabling 6G, and what has the Technology Working Group been focusing on?
Oh yeah, thanks. So Technology Working Group is assessing key 6G technology and research areas that will enable diverse 6G applications and use cases with more stringent requirements in terms of data rate, capacity, latency, spectral efficiency, mobility, coverage, energy efficiency, and so on. The critical 6G technology elements identified by Technology Working Group are grouped into 5 categories. Number 1, systems and network architectures. Number 2, operations, administration, maintenance, often referred to as OAM, and service enablement. Number 3, trustworthiness. Number 4, component technologies. Number 5, radio technologies. The first category, systems and network architecture, address diverse and integrated network topologies supporting drones, satellite, mesh network, device communications, relay, and so on. Systems and network architectures also handles network adaptability as well as distributed cloud and computing. The second category, OAM and service enablement, are important research and development areas to maximally exploit the advantages of cutting-edge 6G radio and core network design. For example, the underlying technologies can provide a means to operate, administer, and manage a 6G network more efficiently and reliably through zero-touch end-to-end automation. They can also reduce energy consumption and generate OpEx savings. The third category, trustworthiness, is one of the audacious goals defined by NGA. It is expected that 6G will become a more integral part of everyday life and the infrastructure that society depends on. This means that security, reliability, resilience, and privacy become even more important. So technologies to ensure that 6G systems are trustworthy include communication security, system reliability, and safeguarding data and privacy. The fourth category, component technologies, address the advances in the component, including semiconductors, circuits and subsystems, antennas, packaging, and testing. Last but not least, the radio technologies are further categorized into 5 areas. Number 1, radio technologies for advanced topology and networking, covering mesh network, device communications, corporate communications, non-terrestrial communications, and so on. Number 2, AI native air interface, including air interface enablement for distributed computing and the intelligence across device and network. Number 3, radio technologies for green communications. And number 4, radio technologies for joint communications and sensing, involving MIMO sensing, RF sensing, cooperative sensing, and so on. Number 5, radio technologies for spectrum expansion and efficiency, such as advanced MIMO technologies, advanced duplex schemes, advanced waveform coding modulation, multiplexes, millimeter wave enhancement, technologies for new spectrum, such as terahertz, sub-terahertz, and the so-called high midband between the 7 gigahertz to 24 gigahertz, and the spectrum sharing technologies.
Thank you, Eddie. Now, as the chair of the Spectrum Working Group, I hear a lot of different terminology when it comes to how people refer to spectrum. Reza, why does terminology matter, right, when it comes to spectrum and 6G?
Yeah, thanks for that question. Terminology discussions might seem boring, and they are often boring because people argue over what's the better choice of, several words that mean the same thing to most people. And it might seem like a waste of time, but using the right terminology is actually the first step in effectively communicating on complex topics, right? Especially if it's a complex topic that a large group of people with different backgrounds and interests are discussing. And spectrum is certainly a complex topic and with global implications. And so in the Spectrum Working Group of Next Year Alliance, we're currently working on developing our views on spectrum for 6G. And sooner or later, we'll need to communicate our ideas externally with regulators, with academia, with technologists. And so it's important for us to agree on a terminology or a set of definitions that those outside North America could easily understand. I'll give you an example. For instance, those of us in North America, we're familiar with the US 700 megahertz, but what is, for instance, D block in the US 700 megahertz, but that might not be the case to people in other parts of the world, or for instance, what EMFAS bands are. So building an effective communication with industry, academia, and regulators, for that, it's important that everything is set on the right foot, and we start using the right terminology.
Thank you for that. Now, as we all heard earlier today, right, when Andre gave his opening remarks, right, he said that this 6G is very dependent upon spectrum. Reza, could you give us a little bit more flavor for why spectrum matters to 6G?
Yes, sure. Spectrum is the lifeblood of any radio communication service, right? Without access to sufficient and suitable spectrum, radio services won't be able to operate efficiently, economically, and rationally. So here I'd like to emphasize on the two qualifiers that I used, sufficient and suitable, right? Both of these are important in order to create a successful technological experience for the users. Having access to sufficient amount of spectrum, of course, seems intuitive because the amount of available spectrum presents itself in the form of, for instance, channel bandwidth, which is directly related to a very important KPI, which is the connection speed and how the user experiences a mobile broadband service, right? But the best and most efficient use of spectral resources could only happen if the radio communication system is using the type of spectrum that's suitable for the services that it offers, right? For instance, give you an example. For instance, a wide area coverage of large geographical areas using very high frequencies would not be the most efficient, economic, and rational way of using spectrum because of propagation losses. And in contrast, in cases with a high density of users in very small areas, this excessive path loss of higher frequencies would be beneficial in limiting intra-system interference and improving performance. So that shows you the linkage between these things, right? And these are examples related to just one KPI, which is the throughput speed, throughput and the connection speed. But other KPIs, for instance, those related to some of the new and innovative applications that people are talking about, have exactly similar considerations that need to be taken into account, and for both sufficiency and suitability of spectrum in mind, of course. And therefore, so these both aspects are very important in both the technology development and also as well as the success of the 6G itself.
Right. Eddie, do you want to share a perspective?
Yeah. So one more aspect that I would like to point out from the perspective of technology development is that new spectrum generally requires a proof of concept of whether and how the new spectrum can meet its requirement in terms of, for example, coverage and the data rate that often involves development of technologies, ensuring that 6G system in the new spectrum works properly. For example, new RFIC, new antenna technologies, and so on.
Right. Okay. Thank you, Eddie. Now, Eddie, again to you, how does the technology working group see going from a broad set of technologies, which is where you've been focusing discussions on so far, to a really focused set that enables 6G in North America?
Yeah, thanks, Andy. Yeah, that's a quite critical question. So most of the technologies mentioned earlier are generally of global interest, especially because a common 6G system will be deployed all over the globe. Having said that, there can be specific sets of the technologies that can be a high priority for North America for different perspectives. One example is a set of technologies that can be leveraged by North Americans' comparative advantage or dominance. For example, 6G technologies for distributed cloud and computing. Another example is a set of technologies needed by North Americans' specific circumstances. For example, satellite communications can be a critical complementing technology to address coverage holes of terrestrial networks, such as areas of mountain and desert. So technology working group is currently discussing and defining in more details technologies and research areas that can be labeled or regarded as a high priority for North America.
Right. Okay. Thank you, Eddie. Now, Reza, from your perspective, right, and looking inside the Spectrum Working Group, how is the Spectrum Working Group going to figure out how much 6G spectrum is actually needed?
Yeah, that's a very good question. First of all, we want to do this methodically. And in order to do that methodically, we need to pay attention to the characteristics of services and applications that will use the technology, but also to the technical capabilities that's being foreseen for 6G. Both aspects are quite important. Characteristics of services and applications tell us about the environments and the conditions in which the systems will operate. And the technical capabilities tell us what the systems will have to offer to support those services and applications. So as we said earlier, the environments and the usage conditions have direct impact on finding suitable spectrum. But on the other hand, technical capabilities also directly impact how much spectrum is going to be needed. So the methodology that we're discussing in Next G Alliance takes all of these aspects together. And so we would like to have a methodology which not only gives us a total amount of spectrum, but we would like to have a method that could also be customized to give us an estimate of spectrum needs of 6G, for instance, in various environments, in various parts of the spectrum, low, mid, high, etc. And we're trying to come up with a methodology that could be customized per application also, or per usage scenario, right? This is especially important because, as we've seen with 5G, the role of non-EMBB, non-mobile broadband use cases, and the ones that, cater to various vertical industries, their role is becoming increasingly important. So it's important to make sure that this customization towards applications is also included in the methodology. And last but not least, we like to have a simple approach. It's tempting especially for engineers, to have a very detailed analysis and fine-tune every parameter, but we understand that as we make the method more complex, we need to make more assumptions, and the more assumptions we make, we would be deviating from realistic scenarios, right? So therefore, we'd like to have a methodology which is simple, but at the same time can give us a rough estimate of the spectrum needs of 6G.
Right now, Reza, I mean, there's always been a drive, regardless of which G, to try to make sure that the spectrum that's available for the technology is contiguous, right? Or at least as much contiguous spectrum as possible.
Yeah.
How important is contiguous spectrum going to be to 6G?
Yeah, the importance of having access to contiguous spectrum still remains. As we know, there's a performance cost associated with non-contiguous carrier aggregation, and this is not expected to go away anytime soon. As the CCs, the component carriers that are supported by the specifications increase in size, for example, 1 gigahertz and maybe larger, this access to contiguous spectrum becomes even more critical. And so we should be looking at this also in the light of how network operators deploy their systems and the amount of minimum bandwidth that they need in order to achieve what the technology has to offer for them. We went from the 20 megahertz of LTE to 100 megahertz of NR, and that affected how much spectrum they needed with contiguous spectrum they needed within their network, and this trend will continue. So accommodating multiple licenses in any given band is again another important factor to consider.
Right. So like you were talking about, right? Minimum bandwidth 20 megahertz for LTE, 100 megahertz for 5G new radio. Eddie, from a technology perspective, right, looking at LTE there and 5G for minimum bandwidth, what is going to make 6G different from 5G beyond just minimum bandwidths?
Okay, thank you, Andy. Yeah, it's a quite good question. So indeed, many people are asking this question. So the answers could be different depending on the different perspectives. But from the technology development perspective, the various 6G technologies are being developed, taking into account more diverse and more stringent requirement by 6G applications and use cases and services, not only in terms of the traditional KPIs, such as capacity, latency, spectral efficiency, reliability, coverage, and so on, but also in terms of KPIs of increasing importance, such as energy and cost efficiency, intelligence, trustworthiness, and so on. So in addition to new 6G radio technologies, such as I mentioned earlier, new spectrum-related technologies, joint communication sensing, and so on, the other key technologies that will make 6G different from 5G are ones for AI native and cloud native 6G systems. And their trustworthiness involving AI native air interface, AI-based network operations, administration, maintenance, distributed cloud and computing, security, resiliency, privacy, and so forth.
Right. So quite a bit of a pool of new technologies, right, that will enable 6G, right, that really haven't made themselves present in 5G. Now, I guess the good news is next up for us is going to be Eric Berger, who's going to be moderating a panel specifically looking at driving 6G research priorities, maybe to help us close some of those technology gaps between 6G and 5G. Thank you very much both for your time today. Really appreciate the discussion.
Thank you.
Thank you.